Okay, so let's do some example problems with multiplying and working with polynomials. Um, First example, we're given p of x and q of x, and it's going to ask us to add them together. So in order to add parts together, they have to be like terms. So let's look at p of x. P of x has a 5x cubed. We don't have any in q of x, so we have 5x cubed. We have a negative 2x squared, and we have a 3x squared. So that's going to add together to make a positive x squared. You have an 8x over here, none over here, so you have plus 8x, and you have a positive 7 and a negative 6. That makes a positive 1. So that's the answer for p plus q. Now, p minus q, we're going to be doing the opposite. We need to take whatever we have from p of x and make sure that we take away everything in q of x. So we're going to be reversing the signs of everything in q of x. So we start off, you've got, of course, 5x cubed. We have minus 2x squared. We have a positive 7. And we're subtracting the whole thing of q. So this is important, especially when you're subtracting. It's very, very important that you group things. It's not as important with addition, but you need to do this in this case. Make sure that you bracket the 3x squared plus 8x minus 6, because when you simplify, you have to distribute that negative to each term. So the 3x squared becomes negative 3x squared, and the 8x becomes negative 8x. And now the negative 6 becomes positive 6 because we're taking away a negative 6, so we add 6. And we need to go through now and simplify. So we combine our like terms. So we're going to get 5x cubed. We're going to have minus 5x squared. We're going to have negative 8x. We're going to have a positive 13. So those are our two answers for p plus q and p minus q. Now, as we move along, one of our questions asks us, next one asks us, what's p plus q of 3? Well, for this problem, we need to go ahead and we need to plug in 3. So we're going to get 5 times 3 cubed plus 3 squared plus 8 times 3 plus 1. And so we can go ahead and evaluate this. 3 cubed is the same thing as 27. 3 squared is 9. 8 times 3 is 24. And obviously we have the plus 1. Well, 5 times 27 is going to be 135. 9 plus 24 plus 1 should give us plus 34. So our final answer is going to be 169. So this here represents the combination of p and q when they're added together. So we need to use that function when we're plugging in 3. Now you could also plug 3 into p and then 3 into q and add those together. But if you already have p plus q, then that's not necessary. Now it's asking us, what's the degree of p plus q? Well, degree refers to the highest or the greatest exponent for our polynomial. So if we go back and we look and we see p plus q, we have 5x cubed plus 5x squared, or plus x squared plus 8x plus 1. So our greatest exponent term is 5x, or is this 5x cubed part. So the degree is what the exponent is. So our degree is going to be 3 for that, because the highest exponent is a 3. Now 2 asks us to expand this term. Well, what we have to do is we're going to multiply each term in each bracket by each term in the other. So we start off, you get 3x squared times 4x. So you get 3x squared times 4x, and then you do 3x squared times 5, so you get plus 3x squared times 5. Then we're going to move on to the 2x. So we get 2x, so we get positive 2x times 4x, and positive 2x times 5. And then lastly, you get negative 1 times 4x. In this case, I've been writing the numbers just kind of side by side because I don't have an x here. I want to make sure that I'm multiplying, indicating that I'm multiplying. And then I do negative 1 times 5. So now you go through and simplify. Take the next step and use that to simplify your terms. So 3 times 4 makes 12. X squared times x makes x cubed. The next term, 3x squared times 5 makes 15. X squared. 2x times 4x makes 8x squared. 2x times 5 makes 10x. And then negative 1 times 4x makes negative 4x. And then negative 1 times 5 makes negative 5. So now we just need to make sure that we combine our like terms. So this just makes 12x cubed. These two together are going to make a positive 23x squared. These two together are going to make a positive 6x. And then we just have our minus 5 at the end. So when you multiply different groups of polynomials, you need to make sure that each term is multiplied by by each term in the next set of parentheses in order to make sure that you're getting every combination right. Now, based off that, what if they asked us a question to find the coefficient of x squared in the expansion of 3x squared minus 4x plus 7 times negative 2x squared plus 8x plus 6? Well, we discussed in the last one, each term has to multiply by everything in the other terms. So like the 3x squared would have to multiply by each of these three. Well, if you notice, these two each have x squareds in them, so that's going to make an x to the fourth. This has an x and an x squared, so that's going to make x cubed. Neither one of those is going to make a term for x squared. So we just need to find the partner for 3x squared in the other set of parentheses that is going to multiply to make an x squared term. Likewise, we want to do that for, we want to do that for every other term. So what would I need to multiply negative 4x by to get something with x squared? Well, I would need to multiply it by a term involving x. So it kind of partners up with the 8x to make an x squared term. It would not work if we did negative 4x, for example, times negative 2x squared. That would make an x cubed term, so we don't use that. So we can be a little more efficient this way. And then the 7 would need to multiply by something involved with x squared. Well, the only thing involved with x squared in the other term is negative 2x squared. So we're going to put all of these together, and that will end up giving us our coefficient that we're looking for. Well, for the green, we've got 3x squared times 6. That's going to make 18x squared. We have the negative 4x times a positive 8x. That's going to make negative 32x squared. And then we have a positive 7 times a negative 2x squared, which makes negative 14x squared. So all in all, we're going to have 18 x squareds. We're going to have negative 32. So 18 minus 32 makes a negative 14. And then we take away another negative 14. So this is negative 28x squared. And so our answer is 28. that is the coefficient that we're looking for at the beginning. So if for whatever reason that's what we were looking for, we can find that inside of this big multiplication. You don't have to go through this big process of multiplying everything out in order to find, one particular term. If we are just looking for one particular term, we can find it by just kind of breaking down what we have in our brackets. Now, to make that a little further, um, if we have things in the same form, we can start to make statements about variables and about coefficients that we don't know. Well, it says let ax cubed plus bx squared plus cx plus d equal this term over here. X plus 1 times x minus 3 times 2x plus 5, all together. So what we want to do is we want to find a, b, c, and d. Well, in order to find a, b, c, and d, we are going to want to turn this side to look like this. So we need to go ahead and expand it all the way out with no brackets. So we have x plus 1 times x minus 3 times 2x plus 5. Well, to deal with a problem like this that has 3 different sets, you're going to pick 2 to start with and then move on from there. So we're going to pick the first 2. So if we were to go through and multiply these down, you're going to get x times x, which makes x squared. You're going to get x times negative 3 to make negative 3x. You're going to get plus 1 times x to make positive x, and then the plus 1 times the negative 3 to make negative 3. Now you can bring this down and say, okay, well, this is now 2x plus 5. So that's the first step. Now we can see we can actually simplify this part in the middle and make it a little bit easier on us. This becomes a negative 2x. And so now we have to do the same thing again. Each term multiplies by each part in the next series. So our x squared will multiply by the 2x to make 2x cubed. Then we multiply the x squared by the 5 to make 5x squared. Then we move along, we pick the negative 2x. So the negative 2x times 2x makes negative 4x squared. The negative 2x times the 5 makes a negative 10x. And then finally we get to the negative 3. We do negative 3 times 2x makes negative 6x. And the negative 3 times the 5 makes a negative 15. Well, if we go through and simplify this, we're going to get 2x cubed. These together make a positive x squared. These together make a negative 16x. And then we just have a minus 15 at the end. Well, if that equals ax squared plus bx, or excuse me, ax cubed plus bx squared plus cx plus d, we can start to make some relationships between these. Well, the term with the x cubed over here corresponds to a, so we get a is going to equal 3. Our b relates to our x squared term. So, well, on the right side we have bx squared, on the left side we just have x squared. That means b is going to equal 1. Then our term that has x involved, c on the right side, negative 16 on the left, so we get c to be negative 16. And lastly, we have negative 15 as what's left over, so we get d to equal negative 15. So this is our answer for this problem. So we want to first make sure that our right side looks like the left side. And then once we do that, we can start to make statements about what these coefficients would be. Now, we could make this a little bit more complex. What if we had a situation where we had, instead of it just being an x squared term like on our right side, we have, x squared plus x minus 2. We've got something a little more complex on the left. Well, Again, we have to make the left side look like the right side, or the right side look like the left side. We have to make them look like each other. This side's talking about x plus 1s, this side's talking about x's. That's not going to work for us. So we need to change one side to make it fit. We're going to take this left side and expand it out in order to get just x terms. So we've got a times x plus 1 squared. We've got b times x plus 1. And we've got c by itself. Well, this a times x plus 1 squared is the same thing as a times x squared plus 2x plus 1. This is the same as b times x plus 1, and this is c. So we can go ahead and break this apart since we're adding all these together. We're going to go ahead and distribute this throughout the whole thing here down at the bottom. So we get the a times the x squared, so we get ax squared. A times the 2x makes positive 2ax. Okay, we get the a times the 1 makes a positive a. Then we move on to our b value, so we get b times x makes positive bx. Then we get b times 1 to make a positive b. And then we have c down here at the very, very bottom. So I'm going to switch colors. Say positive c. So we have all of these. Now we need to arrange these in a way where we can factor and make it look like the right side. So I'm going to put the x terms together, which is the positive 2ax, and I'm going to get the positive bx here, and then we're left with a positive a, positive b, and a positive c. So in order to make this look like this problem up at the top, I've got to factor. I've got to get some term multiplied by x squared. Well, the term that's being multiplied by x squared on the bottom is a. That's good. Now, what terms are being multiplied by x? Well, we've got these two. So what we need to do is, in a sense, we need to factor out our x. So if we factored out our x to make it look like this, some number times x, we need to figure out, okay, so what would we take away, or what would we divide out of 2ax to get, if we took x out? It would be 2a, and if we took x away from bx, we would have b. So the term that's being multiplied by x in reality is 2a plus b. And then finally, at the end, we see that we're just trying to tack on some number, and what we have left is this term a plus b plus c. So unfortunately, we're not done yet. We are going to compare these terms together. So if ax squared equals 5x squared, okay, then we are going to say that a equals 5. Okay, because that's the term being multiplied by x squared, so that's what we use. Now, the term being multiplied by x down here is 2a plus b. So we've got 2a plus b equals 7. Well, we learned earlier that since a is 5, this would be 2 times 5 plus b equals 7. And if we solve, we would find that b is going to equal -3. So we've got that, and we've got that. We've got a to equal 5 and b to equal -3. And now finally, we have, let's see here, we've got our -2 is equal to a plus b plus c. So we go down, and we say, okay, well, a plus b plus c equals -2. Well, a is 5, so we're going to get 5. And then we add b, which we found to be negative 3, and then we add c, and that equals negative 2. Well, this is the same thing as 2 plus c equals negative 2, and then c would equal negative 4. So the way that this system would work, it would only work if a were to equal 5, b were to equal negative 3, and c were to equal negative 4.